Okay, can you hear me? It looks like I just lost the internet connection momentarily.
Yes, can hear
Yeah.
you.
Okay, good. So, and the other motion diagram is going to be this other one here. X-axis is in meters in both cases. Motion diagram for this example. The x-axis is in meters. Okay. What time is that? 10:37, 38. The next thing that I want to do is free fall. Free fall. Okay. Free fall. Free fall is nothing but a special type of uniformly accelerated motion, where the acceleration is 9.8 meters per second square, which we usually approximate to 10 meters per second square to help, to simplify, right? Not to help, but to simplify the calculations, okay? Which sometimes, not usually, but sometimes, so if you understand uniformly accelerated motion, it's not going to be difficult to understand free fall. Okay. Let's get that here. Okay, here you go. Here is the, okay. Here's my motion diagram demonstrating not just the velocity vectors, but also illustrating not just the velocity vectors, but the position vectors from the origin to where it is, right? X1, X2, X3, and so on. Here's the same thing. Not just the velocity vector, we keep on increasing, see that? As the velocity increases, we draw an arrow that's longer and longer. The velocity vector keeps on increasing in size, but the acceleration vector doesn't change because it's constant acceleration. Okay? And look at the position vector. Okay? Here's the case of the acceleration vector that's negative. That's the motion diagram. In this case, we're taking the particle moving only in a single direction. Now, let's see. Now we are going to talk about the free fall. Here you go. In order to talk about free fall, this is exactly what the name says. An object is freely falling from a given position. When the object falls, it's considered free fall. But there is one important play of words here, okay? When I propel the object upwards, it is also considered free fall, okay? I'm going to propel this object upwards. While it is airborne, it's still considered free fall. That's an important definition of free fall, okay? It's not because you have fall in there that the object must be always falling. Okay, fall means moving up and down as well, either way. It's important. And I'm going to write down here the definition of free fall. Definition of free fall. A more accurate definition of free fall, physical definition of free fall, is motion along the y-axis with an acceleration of, I'm going to put here, acceleration is, I'm going to put, there's a letter for that, okay, G. The acceleration of gravity, we write down as G. Okay, with an acceleration equal to G. If the object is moving in the vertical direction and its acceleration is equal to G, then it is considered free fall. It does not matter if the object is moving upwards or downwards. Downwards. Either way, it is still considered free fall, provided the acceleration is equal to G. In the case of the Earth, G is 10 meters per second square. Okay. Now let me illustrate here. Okay, we are going to illustrate the free fall motion of an object. The first thing that you do, you draw the x-axis, draw the origin of the x-axis, draw the y-axis. Don't forget to label them. Y meters, x meter. Here you go. Here's a building. I put that a building, okay? And here's an example of an object under free fall moving downwards. It's at the top of a building released from rest at time t equal to 0. Okay? And we want to know the why not, the initial position of this object, the height of the building, right? Just by timing how long it takes to reach the ground. And by the way, let me write down the equation of motion for free fall first, okay? Before we go into that, and then I can, equations of motion. I'm gonna copy and paste. Remember, free fall is vertical motion that's uniformly accelerated. So the acceleration must be constant, but the acceleration is constant for a given value. And because the object is accelerated downwards, then we must have an acceleration value that is negative, okay? Like that. Or minus 9.8 meters per second squared. Do you see? It's just a special case than what we have studied before. Okay? So if you master accelerated motion, like we have done so far, you will be able to understand free fall. Like that. And then we have this other one. But now, instead of writing X, I'm going to write Y because it's the vertical position, okay? So here you go. I keep my Y naught. Let's say I still do not know what the V naught is, so you keep it like that. And we write 9.8 meters per second square. I don't need the A anymore. T squared. We divide 9.8 by 2. Dividing 9.8 by 2, we get 4.9, right? Like that. Now I'm going to clean all my equations. Here you go. And that's how the equations of motion for free fall. Okay. And we can do our example now. 10:47. Very soon we're going to have our break. Example. An object is released from the top of a building of a known height. Release means from rest, release it from rest, right? From the top of a building of unknown height. The moment the object is released, you time how long it takes to reach the ground. A practical application of those equations of physics, okay? That's what this example is all about. So the moment the object is released, you time how long and measure a delta t of a period let's see here. Not just released from rest from the top of a building of a known height. The moment the object, you time how long it takes to reach the ground, and find it took t equal to 10 seconds. Here you go. Three questions here. One, what's the height of the building? What's the velocity of the object just before it impacts the ground? What is the speed of the object just before it impacts the ground? For simplification purposes, okay? Use, for simplification purposes, use G equal to minus 10 meters per second square. Solution? So suppose that you are at the top of a building and you want to know the height of that building. Get a stone or a little stone and release from the top of that building and time how long it takes to reach the ground. Make sure you don't hit anybody down there, right? The moment the object impacts the ground, you stop your watch, your chronometer. Okay, so the first thing that you gotta do is to write down, let's see, write down, let's see, the equations of motion. Equations of motion of this object. And then what's the height? Then after writing down the equations of motion, what's the height of the building, right? And then what's the velocity and the speed of the object just before it impacts the ground. For simplification purposes, use G equal to 10 meters per second square. Okay, so we are going to use the equations of motion here, uniformly accelerate. Instead of 9.8, we're going to use 10 meters per second square, just because we want to make our lives easier to solve this problem, right? 4.9 becomes 5. And I'm going to put it here. No, wait a minute. Yeah, okay. I'm going to boldface what is not known. We do not know why not. Okay, don't forget that this y here is the final position of the object, right? So that's item A. That's the equation of motion. Oh, by the way, there is one more step that we can do because V naught is equal to 0, right? So make sure we do this step here. V naught equal. And we do not know why not. That's what we want to find out. Those are the equations of motion. As a function of time, as a function of time and its initial position, right? Its initial position, which is unknown. Determine why not? Determine the height of the building, which coincides with the initial position of the object. Okay. Okay. To solve this part of the problem, this problem is a little bit more difficult because it doesn't involve straightforward applications of formulas. Okay. It involves a formula that you already know, but you need to work on that formula to get your result. Solve this part of the problem, you must refer to the fact that the object hits the ground at t equal to 10 seconds. At this instant of time, comma, the final position of the object is going to be what? Is going to be what? According to my drawing here, the ground, the origin, right? Is exactly at the ground. So whenever t equal to 10 seconds, the height of the object is going to be 0 meters. So you have to use this fact, okay? So here is the acceleration vector, right? Don't forget the final position is going to be, let's see, is going to be the ground. Okay. Here you go. And it will be, instead of 7 seconds, it will be 10 seconds, right? Here, you know, let's put y here. Why not? Y final. So let's see, you know, let me copy and paste it so you don't, here we're gonna be 10 seconds. Okay, I'm gonna put here T1, T2, twice T2, twice T1, right? 3 times T1 and so on. At T equal to 10 seconds, it impacts the ground. Make it simpler. Let's put it T2 here. I don't know why I did that initially. Here you go. Make it simple. Let's put this one T3, right? And then it impacts the ground at 10 seconds. We are picturing the problem, having an idea how the problem looks like, right? and going back to the solution of our problem, right? So here we go. Final position of the object is going to be 0 meters because it will impact the ground. In other words, y naught is the height of the building that we still do not know. YF, which is equal to y. YF, which by the way is equal to y, is equal to 0. And YF is y at t equal to 10 seconds. Yeah. And now we can apply our equations of motion. Here we go. At time t equal to 10 seconds, this guy is going to be equal to 0 meters. Y naught is still unknown, and we do know that t is equal to 10 seconds here. And then we have the following equation to be solved. Okay, y naught like that. Let's keep on working this equation. It's going to be 100 second squares, right? Okay. Second square cancel with second square. We have 500. Second square cancels with second square. We have 500 here. 500 meters. We have this equation right in here. Y naught is 500 meters. Wow, that's a tall building, isn't it? So that's what we have it for this. For free fall, we can stop here. We're gonna take a break from 11 a.m. To 11:15 a.m. Okay, and we return for the lab. Okay. Any questions before we go to the break? There is no questions. I'll see you in the next 15 minutes. Bye-bye. I am back here. Let's see if everybody has a group member, right? Lab. Yeah, the first thing I want to ask you if everybody has a group member. Okay, that's the first thing that I want to ask you. If you don't have, let me know. There was a student who told me that she was having problems contacting her group, her colleague, right? Her classmate, her group classmate. And Let's see. Let me see here. And who was that? Who was the student who could not get hold of
That was me, Professor Delisha.
Delisha? Okay, Delisha. Which group number are you, Delisha?
Group number 4.
4. Let me organize my spreadsheet here for group number. Okay, group 4. Okay, Delisha, so your group member is Madeline Brock, right?
Yes.
Okay, and let's see, it's Madeline here. According to my latest roster, she is still in the class, okay?
Okay.
Okay, according to, let me check in this, let me check the college website if she dropped today, lately. Let's see, login.
Professor, I also don't have a lab member.
Okay, you are Isabel?
Yes.
Okay, Isabel Medina. Which group number are you?
I didn't get assigned any.
Ah, you didn't get assigned any group. Okay, I got it. Okay. Yeah, okay, so let's do the following. Why don't you join Delisha, right? Let's do that, Delisha, since you are by yourself, and then if Madeline come back, you stay with like 3 students in the group. Let's do it this way.
Okay, sorry, who was my new group member? Isabel?
Isabel Medina, yeah.
Okay, great. Thank you.
Okay, so let's exchange contact information. Okay, Isabel, with Delisha, is exchange your contact information. You can do that in Canvas. And now, anybody else doesn't have a group member?
Yes, I don't have a group
You
assigned.
don't have a group? Cat?
No.
Paris? Okay, let's see.
Yeah.
Cat Paris. Let's see. Oh, Catherine Paris. Okay, I see it. Let's see. Oh, I'm gonna take attendance. Let's see who doesn't have cut. Insert cut cells. So let's see. Evelyn Ayala. Is Evelyn Ayala there? I don't see Evelyn here. That will help me organize better this lab. Let's see here. Number. Now, Miesia Bragg. Don't see. Yeah, I don't see her here. Bragg. Isabella Cisnero. I don't see Isabella Cisnero either. Jacob Contreras. I don't see Jacob Contreras here. Next, Arturo Laguna. Okay, no Arturo. Catherine's here, right?
Yes.
Elizabeth Saldana. I don't see Elizabeth either. Next, Jenia Tapia. Janya Tapia, I don't see either. Next, Sinue Abundit. Hey, wait a minute. Sinue drop. Let's see here. Jacob is here. Jacob. Hello, Jacob. Can you hear me, Jacob? Okay, I'll get back to you soon. Let's see what's going on here for some reason. Huh. Okay. Yellow. Okay. Hmm. Oh. Ah, I see what happened. Let's see. No, that was not a problem. Okay. I see. Three spots in research. Okay. So Madeline Brock. Yeah, okay. So I just found out that Madeline Brock did drop. Okay. So that's let me organize this thing here. Madeline Brock. Intercambulario. So Delisha, don't forget to share the link of the group folder with your new group member, okay?
Okay. I will do that now. Thank you.
Okay. Dropped. Jacob Vedas. Okay. 36. História parabéns. Okay, so let's see. Eric Alcala, are you there?
Here.
Okay, do you have your group member there?
Yes.
There should be Edith, right? Edith, are you there?
Yes.
Okay, thank you. Jawaidia Ali.
Hi, I'm here. Present. Sorry.
Thank you. Next, Evelyn Ayala is not here, right? Okay, Ben Bendoy.
Yeah, I'm here.
Okay, good. Do you have your group member there with you?
Yeah.
Who is Melissa, right? That's Melissa. Yeah, Melissa is here. Miesha is not here. Next, Queen Castaneda.
Hello, I'm here.
Okay, you have a group 5, right?
Yes.
Your group member is Emily. Emily, are you there?
Yes, I'm here.
Okay, what about Simone Cato? See, I don't see Simone here. Cecilia Chavez.
Good morning, I'm here.
Okay, your group member is there with you, Cecilia?
Yes.
Okay. Okay, who is your group member, by the way?
I'm by myself.
Oh, you're by yourself. Okay. So Isabella is not here, right? Jacob Contreras. Are you there, Jacob? Oh, must be sending a message. Let's see here. Oh, yeah, good. So your group member is here, Jacob. Oh, you don't have a group. Okay. Jacob doesn't have a group. Would you like to work with Jacob, Cecilia?
Sure, that would be fine.
Okay, so makes things easier for me, so I don't have to create another folder, right? So Jacob, get in touch with Cecilia Chavez, and Cecilia, share the folder link with him, please. Delisha, you already have a group, right? A group member.
Yeah, group 4 with Isabel.
That's right. And Gabriela Edwards. Let's see Gabriela here. Gabriela seems to be here.
I'm here.
Yeah, your group number 6, right, Gabriela? Do you have a group partner?
Yes.
Oh, okay, good. Who is that? Who's your group partner, by the way? Six. Oh, it's Carlo Gallardo. Okay, good. Angelica Franco.
Here.
Okay. Okay, now I can share the screen. Makes sense. Okay, so Princess, are you?
Hi, I'm here.
Okay, do we have a group partner?
Yeah, I'm with Angelica.
Okay, yeah, okay, good, Angelica. And Carlo, are you there? Carlo Gallardo?
Yes, I'm here.
Okay, good. Your group number 6. Brandon Guerrero.
Yeah, I'm here.
Okay, do you have a group partner?
I think it was Janie.
Yeah, Janie. Okay, good. Janie, are you there?
Yes, I'm here.
Okay, thank you. Sydney Hill. Is Sydney here? Sydney seems to be here. Sydney, your group number 11, right? Okay. Okay, good. So Isabel Medina, group number 4.
Yes, here.
Okay, thank you. Kimberly Morales.
Here.
Okay, good. Montserrat Morales.
Here.
Thank you. Erika Nusa. I don't see Erika. Okay, Erica dropped. Okay. Let me organize. Next, Cynthia Ozuji. Cynthia also dropped. Arwa Paris.
Yes, I'm here.
Okay, you have a group partner, right? Yes.
Yes.
You have. Okay, good. Catherine Perez already called you, right? And which group are you, Kat? Assign you to group number.
I still don't have a group.
You don't have a group? Okay. Okay, so I thought I had assigned you to a group. Okay, I'll get back to you, okay? Let me.
No worries. Yeah.
Okay. Nicolas Rivera.
Yes, I'm here.
Okay, do you have a group partner, Nicholas?
Yes, I do.
Okay, good. It's Jason, right? Jason is the partner of Nicholas, right?
Yes.
Okay. Jason, let's see, Elizabeth Saldanha. Let's see, Elizabeth Saldanha must have dropped. Saldanha. No, she didn't drop. Are you there, Elizabeth? Nope, she's not. Next, Jason Cervellon. Okay, already called him. Armand.
Yeah, I'm here.
Okay, do you have a group partner?
Yeah.
Yeah, okay, that's one, right? Right in here. Okay, Jenia Tapia. Yeah, not here. Stacy Telurincon. Let's see here. Yeah, Stacy also dropped. Let's put it here. And Juan Torres Arellano. Juan doesn't look like Juan is here either. Juan Arellano. Juan Torres. Torres. Okay. One is didn't drop yet. Okay, so now let me organize by groups. Okay. Name, group numbers. Okay. Group number 223344. Okay, it's Michelle that doesn't have a group, right? 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11. Okay, so it's Cecilia that has, no, Cecilia has a group. It is Armand that's alone, right, Armand? Your group member, oh no, Armand is the group of Sydney. Okay, 12. So it looks like it's Cecilia that doesn't have a group partner. Oh no, Cecilia has a group partner right now. Okay. Well, do you know anyone that you in the class here, Catherine?
No.
You don't know anybody? Okay, so I'm gonna assign you randomly to a group here. Okay, let's see. Okay, so I'll put you in group number 2. Okay, Jawaira and Awa. I'm gonna put Catherine in your group. That's okay?
Yes, that's okay.
Share your contact information among yourselves. So Catherine is going to be Jawairia and Arwa. You're going to need a group folder link, okay, that I gave to them. I'm going to put here group number 2. If more students later on, more students come along and doesn't have a group, then I'll pair you with this other student that shows up, okay? So we
Okay.
have, let's see, we have how many students today? We have 23. Yeah, since we have an odd number, but wait a minute. See, okay. It's not 23. It is, ooh, I gotta fix that. Here you go, 25. Okay, now this number matches. Good. And what I'm gonna do now is upload the spreadsheets to your group folder, and we're going to start working on the first lab. And as we go along, I will walk you step by step what you are supposed to do. Okay, so divisional parameter, illustration, labs, raw data, lab 1. Okay. Nine. Let's open everything here first. Those labs are described in my lab manual, that I have out there. Okay? But you can also look at the notes of last semester too. The note of last semester has some descriptions. We just have a student joining us. Let's see, sample. Okay, this one is good. No problem. I'm going to upload the spreadsheet that you're going to work with, and then I will walk you through how everything is going to be done. Let me just review those spreadsheets, make sure everything's in the way I want. Okay, copy. This one here. One. If necessary, we'll repeat this lab next meeting. Go. Okay, this one here, let's see. Yeah, this one has this other one. Now must be. Yeah, this one is good. Group 9. Sample. 9. Well. Oh, I see. This is the one. Okay, now copy folder. Okay. Let's take a last look here at those files before I upload them. Gosh, I hate that. Yeah. Note that you have several tabs here. We're going to use only this lab number 1 tab. Ignore all the remaining tabs. Let me write that down here in my notes. Lab number 01. 1. The spreadsheet for today. Lab has several tabs. We will use only the tab lab. Let's see how I wrote that down. Number 01. Lab tab name lab 01. You may ignore everything else. You may ignore the tabs. Let's go right here. May ignore the remaining tabs. You may know, you must. Okay, let's put it this way. You must ignore the remaining tabs. That's good. If you may, make sure you delete them, otherwise it's gonna be too much work for me to delete it, Don't delete the lab number 01, delete the 02, 03, 04, and so on, okay? That's good. I presume everybody has a group partner right now. If you don't have, please let me know. Gotta close this thing. Okay, now I am going to go to my Google Drive. Google Drive and upload the spreadsheet that you're going to use. File folder. Okay, it's a total of 12 groups. Okay. Group 1. Lab 1, right here. Lab 1. Lab 1, group 01. Do not change the title of the file, okay? Group 2, leave this way, P06, L01, G01 or 2 or 3, depending on your group number. 4. Group 1 through 4, you can start downloading your spreadsheet. Group 5, group 6, group 7, group 8, group 9, okay, group 12, group 11, and group 10.
Professor, just to confirm, you said we can delete the sheets 2 through whatever that number was, right?
Yeah,
Just keep number 1?
Yeah, just keep number 1.
Okay, cool.
So you don't get confused. Keep lab number 1, and let's see if everybody has their folder. Yeah, has a group 1 has your spreadsheet. Group 2 also has a spreadsheet. Group 3 has a spreadsheet. Good. Group 4. Group 5. Download, like again, download the spreadsheet I just uploaded. Download to your hard drive the spreadsheet I just uploaded to your group folder. 9, 10, that's good. 11, and 12. Good. Everything, all the other groups are blank. All the other folders are blank. Okay. And let me give you a heads up what we are going to do in this lab. You must ignore the remaining labs, remaining tabs. Okay, what we are going to do today? What are we going to do today, right? 1. The data you have is real life data obtained during an actual experiment in the classroom. Okay. The data, the raw data, has the diameter of 6 different spheres. I'm gonna put Here you go. 6 different spheres. Let me show you how they are documented there. One. Okay, so here you go. Well, before we talk about the sphere, just go here to the top left in your spreadsheet. Make sure you put your group number. Very important, because I'll be correcting those spreadsheets, and your names. Group student number 1, student number 2, at most 3, right? Student number 3. Put your names here, so I can consult who did that whenever I'm correcting this spreadsheet. You go. First thing. 2. Enter your group number and names of the group partners on the top left of the spreadsheet. Okay? Start like that. Start like that. First thing you do is to fill up your names. And then what do you have? Okay, in this experiment, the diameter of 6 different spheres that were provided, 6 different spheres of steel that were provided to the students in the class. Okay, and here you go. Here you go. I have this table also that has that you must document the density of the steel, and the actual data is the diameter of 6 different spheres. Okay, those diameters, they are in a special format that you need to change, and everything must be written in terms of the International System of Units, meter, kilogram, or second. I fill up the units of just a few of them. Okay, here's the meter, and then here's going to be what? Here's going to be what? Everything is going to, and here is the volume of the sphere. Okay, here, what you see right in here is the actual data, the raw data. Okay, having the diameters with the diameter of the spheres, but with one important detail. In this column, the diameter of the sphere was measured with your regular ruler. Okay? Everybody's familiar with the ruler, right? Here, the diameter was measured with a different instrument. It's called the vernier caliper. It's a fancy ruler. I'm going to elaborate on that. And in this other column, we have the diameter of the same spheres. Okay, see that? Sphere 1, 2, 3, 4, 5, 6, measured with a different instrument called the micrometer. I have my own micrometer here. I'll try to find my vernier caliper so you know, so you have an idea how it looks like. Here you go. Here's my micrometer. It's a very nice instrument. This one is a manual mechanical micrometer, but nowadays we also have electronic versions of this device. It's a very sensitive device. You must be very careful when you're handling it. And what's the difference between those 3 instruments? Let me get let's see if I can find my vernier caliper, okay? This micrometer I bought in 2003. This device here, I bought in 2003 and still worked very well. It's a very nice instrument. I'm proud of it. It can, and I'm going to tell you what's the difference very soon. Ruler, everybody knows how it looks like, right? So I don't need to show you my ruler. Here is my vernier caliper. Came in this nice wooden case. It looks just like that. It's like a fancy ruler. Both devices, both the micrometer and the vernier caliper, are two different fancy rulers. We use those instruments in the shop, in research. Okay, when I'm doing my experiments, I'm measuring, my stuff either with a ruler, with a vernier caliper, or with a micrometer. And we performed this experiment with those three instruments. And what else? Everything that you see here is what I call, again, raw data. Raw data that comes from your measurements. Let's write that down in my notes, so you have everything documented. What are you going to do today? The data you have is real life data obtained during an actual experiment in the classroom. The raw data has the diameter of 6 different spheres of steel, made 6 different spheres made of steel. Okay, each of these is the diameter of each of these spheres. The diameters of each of these spheres were measured with 3 different instruments: the ruler, the vernier caliper, and the micrometer. Very soon I'm going to tell you the difference between those two instruments. The last column also have a set of raw data. The last column have a set of raw data as well, right? Let me erase that here. Let me see if the last column, here you go, right in here. I'm going to highlight it as yellow. Everything is yellow is raw data, measurements, okay? And this last column is a column of the mass of the spheres. Raw measurements as well. It is the mass of the corresponding spheres. Okay? These masses were measured, of course, using a fancy scale. Okay, and I'm going to elaborate in this scale. 12:01, right? We should have a break. Let's wait until 12:05 and we take a break, okay? These masses were measured using a fancy scale. Okay. On the top of that, we have 3 additional columns, right? We have 3 additional columns. I want you to get familiar with, here you go, 1, 2, 3 additional columns with results. Okay, remember, measurements versus result. There's a difference between measurements and results. Measurements are obtained with an instrument. The results are obtained by manipulating the measurements. Okay? Measurements versus result. Do you understand that? Manipulating mathematically, right? The measurements. the results in these columns are the volume of each sphere. And the volume of each sphere, you know what the equation for the volume. We memorized that in school, right? Here you go. Volume is pi r squared. Okay? That is the equation for the volume. Of a sphere, for the volume of a sphere. Different solids have different equations, have different formula for their volume. In the case of a sphere, that's the equation. But we are not measuring the radius of the spheres. We're measuring the diameter of the sphere, right? So we must rewrite this equation in terms of the diameter of the sphere. And I'm going to do that. Oops, it's not square, sorry. It's a volume, right? Should be which power here? Nobody picked up on that, huh? Even I almost didn't. Which power should be right in here for the volume?
Cubed.
Yeah, it's the cube, right? Yeah. Here you go. Thank you. But we want to write this equation in terms of the diameter, not in terms of the radius, because the diameter is the actual measurement. And the radius is equal to half the diameter. Okay? And when we rewrite in terms of the diameter, we get d to the cube 2 to the cube. Highlight, copy, and paste. Here you go. We can go a next step. Here is going to be 8. The 8 cancels out with the 4s, and we end up with 1/6. The ratio 1/6, right? D cube 1205. We're going to get our break very soon, so you can rest a little bit. Oops, 1/6. Okay, that's the equation that we have in those cells of the volume of your sphere. Okay, 4/3 of pi d over 2 cube. Okay, for the ruler, vernier, and micrometer. And let's take our break now. Oh, 12:06 already. Yeah, let's take our break before time goes by, right? Break between 12:06 and 12:21 p.m. Any questions so far? Okay, time is on.
Hi, Professor. So far I have that you just want us to enter the theoretical density and the units of measure.
Yeah, you can
Okay.
check. You can check the for the density. You can check the internet for the steel, right? You can check the density for the steel.
Okay, but other than that, so far that's the only 2 things you want us to enter on that spreadsheet.
Yeah, that's right.
Okay. Okay, thank you.
See you in 15 minutes. Stop sharing. Okay, I'm back. Okay, so now that you have everything that you need to start working, okay, here you go. Here is the volume. What are we going to do? Let's put it here after the break, huh? Like that. What are you going to do in this lab? We will, based on these measurements and results, we will plot mass along the mass along the vertical axis and the volume along the horizontal axis. Here you go, M versus V. Why do you do that? Why are you going to do that? There's a reason. To do that, we're going to do that because we will do that because of the following relation for the density, okay? The density of a material, right, is given by what? Oops, not this one, you go. Nope, this one. Let's see, yeah, rho. The density is given by the mass divided by the volume. Since all spheres are made of steel, all the spheres have the same density. Different masses, different volumes, but same density. So the ratio of those two different measurements, of those two results, of this measurement and this result, right, should be the same. So if we rewrite this equation in terms of the mass, we have, what do we have? We have a linear relation between the volume and the mass. Okay? And when you plot, so what you have to do? You must plot, okay? That's the very first thing we do in the lab, okay? The very first thing we do in the lab is to plot our graph first. And then you work on the rest later, okay? The most challenging one here is to do the plots, okay? You must plot M, just the mass along the vertical axis, and the volume, you must plot the mass along the vertical axis and the volume along the horizontal axis, M versus V. So let's do that now, okay? Get your spreadsheet. I want you to highlight the numbers in the column here. Let's start with the ruler, and then we worry about the rest, okay? And then you highlight the volume obtained from the measurements of the ruler. Okay, and I want to use a different spreadsheet, not this one. Let me get that. Here you go. Yeah, I want to use those. Okay. And then let's repeat what I did, right? And the other thing that I didn't tell you, you gotta go to the internet and get the density of steel, okay? We're gonna do that together. That's I'm gonna highlight here what is measurement, raw measurement, and the rest in this table are just results. And let's take a look at the density of steel, and must be in kilograms per cubic meter, always in the SI units. Okay, density of steel. You still have different densities depending on the type of steel. Depending on the type of steel. It has a range of densities, but the range is very narrow. It's not that much different, okay? It's 7,700 to 8,000. It's like 3 out of 100. It's just 3% variation. A little bit more than 3% variation. You can do the math, okay? The range of variation is 3 to 4%. So it's not, it's okay for you to take the average value that we find out there in the internet. Depending on the type of steel, depending on the type of alloy of steel, we get different densities. Depending on what goes in the mixture of the steel, right? See here, factors influencing steel density. Alloying elements. Steel is an iron-carbon alloy. And what means alloy? Alloy means that the iron is mixed with other elements. It can be carbon, can be manganese, can be chromium, can be nickel, okay? Whatever you put there in the mix is going to alter the density, but within a rather narrow range. It's not that a wide range, okay? So you can take the average of this value and put there in that very first table, 7,750, 8,050, okay? Here you go, I'm gonna put it here, 7,750, 8,050 divided by 2. Here you go. So if you change the format, okay, it's a very inconvenient to see this number in this notation. So I need you also to change the format of the cell. Instead of scientific notation, let's put that in numeric format with 0 decimal places. When you do that, now we see the actual number, 7,900. Okay? You can do the same for these numbers, but eventually you will need to display them with the proper significant figures that we still have to cover that. But for now, let's just, put a smile in our faces and let's plot the mass versus the volume of the ruler. Insert, chart. Do you see that we get sort of a straight line, right? Just this, looks like this data point is a little bit off, but that's okay. In general, it's not just this data point, looks like this one too. Those 3 seems to be a little bit off, but here you go. Click one of the data points, right click, add trend line. Display equation on chart, display R square. Let's see here. So you can see the equation. And here's my equation. Y is going to be the M, the mass, right? X is going to be the volume. And that's where we go ahead and we come up with the chart elements. Primary horizontal. Oops, nope. There's something strange here. Here you go. Axis. Okay, we keep the axis. We don't do anything. Axis title. That's what we have to do. Primary horizontal. Primary vertical. Do you see that this Excel, he come up with a line, with straight line, that's sort of an average of the data points, right? It's not the straight line, it's not a straight line that goes like that. It's not a straight line that goes like that, but it's a straight line that has some of the data points above it and some of the data points below it, right? So it's a statistical technique, right? That we use to come up with this equation. And there is, like I said, there is a proper procedure to do that we don't cover in this course. And now, there's something wrong here. Why is 8, 9, 8, 9? Note C, note C that we got a slope that's relatively high. The slope is supposed to be the density, right? Notice that we got a slope that's relatively high compared to what we were expecting. Okay? Notice that. Most likely, it is because of those data points here that has the combination of those data points. It looks like it's biasing the curve towards a higher value. 1,000, we're getting 1,000. We're getting more than 10% difference from the expected value. But that's okay. That's okay. Look at the R square, 0.9927. Okay. And don't forget, let's put the axis title, right? Here is going to be the volume. You put between parentheses the unit of the volume, that's the cubic meter. Make sure you increase the size of this font as well. Otherwise, it's going to be very difficult for me to see whenever I start correcting. Numbers, you go, scientific labels, tick marks. Let's see, where is the scientific? You don't want in scientific format. Yeah, that's okay. It's okay to put in scientific format. That's 10 to minus 6, 2 times 10 to minus 6, 3 times 10 to minus 6. Okay. And then we need it would be nice to increase the size of this font. Let's see where increase the size. Text options. No, it's not here. Let's see. Click the axis, right click. Delete font. Yeah. Let's see if we can increase the size. Yeah, see the size is 9. The font size must be at least 12. Okay, maybe even larger if it still appears to be small. And I also prefer that you make it a boldface. Let's see how it looks like. Okay, start to be a little bit better to see, right? I would recommend if we go to 14. Let's go to 14. Okay. And here, I like it 16. Boldface too. How do we do that? Let me click outside. Click, right click, font. Regular, we don't want regular. We want bold, and we are going to use 16. Size 16. Okay, and there is one more thing. I want this cube here to be a superscript. Okay, superscript. Highlight the tree, right click, font, superscript. Oh, no, I put sub. Yeah, let's do it again. Highlight, font, I put sub. Okay, it's supposed to be super. Now we got it right. And if you have time, make it italic as well, so it can look nicer. The volume, I make italicized volume. And then we repeat for the other axis. The other axis, notice that we have 0.5, 1, 10 to minus 2, right? That's the mass. That's the mass, okay? In kilograms. 2 times 10 to minus 2, 2 times 10 to minus 2. Because those two numbers are repeating, I recommend that you increase, let's see what's going on here. Not what I want. Let's try it again. Double click. Okay, now I got what I want. Okay, go to number. I recommend you increase the number of decimal places to 1, so you can see a difference between this number here and this other number, okay? Now we see it, right? It's not 1 and 1. No, one is 1, the other is 1.5. One is 2, the other is 2.5, right? Or if you think it looks better by just putting a regular number instead of a scientific format, just put it as a regular number, but put enough, make sure you put enough decimal places here to see the difference, right? We want to do it bold-faced as well to keep it consistent. and increase the size. Both, the size should be, I put 14 in the other. Yeah, I put 14 in the other. Yeah. And axis. The axis is going to be the mass. Yeah. Mass, put in between parentheses kilogram, and we are going to increase the size as well. It's going to be 16 bold-faced. Bold-faced. Right? And that's our graph. Our first graph. Is there anything else that we could do? I think so. Do you see we have this big space here? There's no need to have this big space. Okay? So instead of going to 6 times 10 to minus 6, we can stop at 5 times 10 to minus 6. Okay? 5 times 10 to minus 6. Right in here. Yeah. And you might want to stop at 0.045 as well, because there's no need to have this blank space here either. 0.45. Okay. Can you make this box larger? Yeah, we can make this box larger. Let's see. You know, because it's too small for us to see, right? So click the box, right click, font. Font. Okay, size. Let's put 14. Yeah, now it's better to visualize it. Okay. Everybody's doing that. Let's see. Someone has a chat message here, right? Let's see. Armon, can you do that again? Let's see. 1231. What was that? What do you want me to repeat, Armon? I missed your message. The timing of your message. Are you there, Armon? Okay, how to get the highlighted into a chart? But what do you mean highlighted? Are you talking about the subscript? Are you talking about the superscript? Are you talking about what? Oh, okay, to plot. You're talking about plotting, right? Yeah, okay. So, yeah, okay, let me repeat that, how you do it. I forget, that's a new piece of information that I didn't tell you yet, right? So what do? You highlight the mass, right? Highlight the mass, and then you highlight the volume. If you don't do anything, look what's gonna happen. I'm gonna highlight the volume without doing anything else, but just highlighting. When I highlight the volume, the highlighted of mass disappear, right? Maybe that's the problem you're having, right, Armon? Okay, so how do you fix this problem? Okay, I'm gonna do that again. Highlight the mass. And if you are using a PC, a Windows computer, you click the Control key, and then you highlight the volume of the ruler. And now the two are highlighted simultaneously. That's the little trick that my students in general don't know, right? And now you can do the plot. Insert, chart, and plot again, right? Did you manage to do that? Not just for Armand, but for everybody else, right? And then you can, spice up the graph, make it look nice. And we did that just for the ruler. But let's do something else before we plot the other two graphs. We're going to have 3 graphs, right? 1242, we'll have to meet again on this on this experiment, right? On this lab next time. But let's do something else before we plot the next graph, okay? We're gonna get this number, my slope, 8948, okay? And we are going to go to the bottom of the table at the bottom. And we are going to type 8948 here for the ruler. See slope of the ruler, 8948. And then what you're going to get? We are going to get a percentage difference that's right here. I'm going to change font, format, the cell format in numeric format. See, we're getting a 13% difference between the density that the internet provides us and the experimental density that we are obtained with our measurement, with our ruler measurements. Okay? And there's a reason why the percentage is so high like that. The reason that percentage is so high like that because it's very difficult to measure precisely the diameter of a spherical object with your ruler. It's very difficult. Okay? Whereas with this guy right here, you can just clump it, your sphere between those two jaws, or even the micrometer, right? You can clamp a sphere right in here between those two little jaws of my micrometer. But the ruler doesn't have this facility. So most likely, that's why we're getting a relatively high percentage difference. The problem is in the convenience of the instrument. I would expect that 13%. I would expect that the percentage difference for the vernier and the micrometer to be smaller. The percentage difference, I would expect, but we didn't do that yet, so you do not know for sure, right? Let's see. I'm going to change. Any questions? 12:44, 6 more minutes to go.
Professor, I just have one question. We can find this recording that you're doing right now in the assignments or the modules of Canvas.
Yeah, You can. I'm gonna post this recording, and I also posted last year's recording when I taught this course. Okay, so you can use, to post today's recording. It's not gonna be right away because it takes time for the Zoom to download everything to my computer, right? And then it takes time for YouTube to process everything and display. But you will be able to have ready access to the class, to the lab, the same lab that I taught a year ago, there in Canvas. Okay.
Yeah.
So if you're in a
Thank
hurry
you.
to see, if you're in a hurry to see how to do that.
Okay, thanks.
Okay. But we're going to be doing that over and over again. You're going to get good at it. You're going to memorize it. Okay. Any more questions? Okay, the next step would be to plot another graph, but instead, let's go there to Canvas so I can show you where is, here you go, Canvas. Okay, and courses, 11,200. Okay, videos, home. Okay, 2024 videos. See that? That's 2025. Let's take a look at 2025 videos. I posted the video of 9 of September 2025. I posted the video a week ago. Okay. Wait a minute, there's something wrong here. Today, I didn't post the video of the 12. Let's see here. we're supposed to have the 15th of September video, right? Looks like I didn't post this. Excel plot. Yeah, that's right. I didn't post it. The 15th of September video. What a shame. Forgot completely. Okay, so I will be posting the Monday and the Wednesday video. Okay. Feel free to remind me. Sometimes I forget those things. Okay. And if you go to the 2024 video, you go. Excel graphs, confidence level in 1D motion, 1D motion 2. That's lab 1. That's lab 1 of September 2024. So everything that I'm doing right now is posted here. And notice that I repeated lab 1, right? Repeated lab 1 because the first time they're being introduced to all that stuff and I like to take my time. Okay. I repeated lab 1 here. Okay, that's 12:48. Any more questions?
Professor?
Okay, I think we can stop here now and I'll see you. Let's see, someone has a question here. I'm getting 2 dots when I do that. 2 dots. What time? 12:41. When you do what? When you plot your graph, Jacob? Oh, you figured it out. Okay, thank you. Okay, so I see you Monday, next Monday, right? Thank you for being here.
Thank you, Professor.
Welcome.
Thank you, Professor. Have a nice day.
You too.
Professor, when is this due? The lab that you're requesting or the data on the chart that you're requesting?
Okay. It's not due yet. Whenever we are ready, I'll let you know. Okay. First, you are learning how to plot the graph, right? What the data is all
Yeah.
about. But maybe it's going to be due in 2 weeks. Maybe that's my estimate because we're still going to go through this graph again, through this lab again next Wednesday.
Okay. So
And
it's not
then
like due right away or anything.
it's not due right away. It's going to be due in 2 weeks. Okay.
Okay, great. And then just to confirm one more time, you said attendance is not mandatory. We're not getting docked for not being a part on Mondays, right?
Yeah, that's right. That's right.
Okay,
Monday,
just making sure.
Monday is a lecture, and I think that the lab is important because it's not you cannot find information everywhere about the lab, right? So it's important for you to be here for the lab.
Yeah, of course. Okay, just making sure we're not like losing points for not being at lecture.
Okay.
Okay. Thank you.
Welcome.
Thank you, Professor.
Welcome. Now, this Princess is asking if it's due today, right? No, it's not due today. Let's see. Thank you. Okay.